Hey everybody, it's Mike from Proof Suite here, and in this video, we're going to take our DeFi powers to the next level by actually executing a DeFi arbitrage trade. So that will consist of having a smart contract that can actually read from the Ethereum blockchain from the Uniswap decentralized exchange as well as the Kyber decentralized exchange. These decentralized exchanges are completely censorship resistant. You don't have to create an account for them. All you have to do is have Ether, as we kind of covered in the last video. And this obviously opens up potential of trading and markets to billions of people who wouldn't otherwise have access. Now, of course, that doesn't mean that billions of people are automatically going to just come on and do that. But the fact that the access is there is really powerful. So these markets have a great opportunity of growing in volume over time, but it's going to take more efficiency. So the fact is that DeFi actually needs arbitragers such as yourself to come in and find discrepancies between different token prices on different exchanges so that the decentralized financial markets actually can have more liquidity and more efficiency as far as like the price to like the higher volume venues like that are on like that traditional financial institutions run, OTC platforms run, and centralized exchanges run. So the world of DeFi needs arbitragers, and there's a lot to be potentially gathered from that. Now, obviously, this is just your second class, so you should take this as just a beginner crash course in this. But we are going to deploy a smart contract that can read from the blockchain from two different exchanges. They're decentralized, and then actually execute trades synchronously, one after the other. And so that if the arbitrage or the profit isn't there, the trade won't happen. So it's basically like if you get that right. So you need a node application, which is just a cloud centralized server that monitors the blockchain, looks for the opportunity, and then when the opportunity does exist, can call your smart contract that can then execute that trade in a risk-free fashion as far as if it actually executes or not. If the opportunity is gone or something happens, or you got front run, then your trade just won't go through because you'll see what the prices are at the moment of execution. So in this video, we're going to talk about how to do that, and here we go.
All right, so let's do some arbitrage. What we're going to do here is we are going to buy Ethereum on one exchange, and then we're going to sell Ethereum on another exchange. So the way this is set up is that actually you're going to need to edit this contract very slightly in order for your homework assignment. I'm going to go through this video and explain exactly how everything works, and it'll be up to you to fork this repository, the OrFeed repository, and then actually deploy a arbitrage contract that will actually make money. Now, this one is a contract that checks maybe the wrong currency, but you would just switch out the contract addresses for the right currencies, the right cryptocurrencies. And then maybe it's looking at the buy price or the sell price wrong. So you would find out which one is doing that. And by going through that process, you'll actually be able to add many different cryptocurrencies and many different exchanges and swap platforms so that you can actually execute ARB. So I feel like this is a better way of doing it than just kind of putting code out there that's like, hey, just copy and paste this, which you could do for this one, and it will work. But it probably won't work in the way that you'd want to if you were trying to make money, right? So I'll leave some hints throughout the video, and we'll talk about kind of how to do that. And in the GitHub repository of OrFeed, you could actually come in here, and if you're having issues with the homework assignment, just go up here and say there's issues. Just click on that and just add an issue. Okay, so basically, here we go. Let's get started. I'll first start with the Solidity smart contract. Now, of course, I'm using Etham, and I have the Solidity reader. At the top, we have an example dApp. So you could actually go and check out this dApp by copying and pasting this in. This allows you on Etherscan to read and write to a contract. So of course, you'll need your MetaMask to actually interact with it. But for reading, it's very easy. So what the contract that we're doing now will do is it'll allow us to get the buy price on Uniswap, which is currently $178, $174.82, 2324200, and the Kyber sell price, which is 1732. Now here's how it works. Very, very simple about how ARB works. When you execute ARB, you want to buy on one exchange for one price and then sell on the other exchange for a higher price. So ideally what we want to do here is we want to buy Ether at $174, and then we want to sell Ether, or sorry, we want to buy Ether like at 170, anything below $173. Because if we just had get Kyber buy price, that won't tell us anything. If you're not familiar with spreads, that's what a spread is. For any stock, for any cryptocurrencies, there's always a buy price and there's always a sell price. And if a asset is very liquid, meaning that there's a lot of trade activity, there's usually a very low spread, meaning that they might even actually, there might not even be a spread. That's the ideal efficient market. There's no spread, right? And so for your most popular stocks and things like that, there are. But like, for example, like corporate bonds and stuff, there's usually pretty big spreads, right? Cryptocurrencies, there's usually pretty big spreads. You can even get into the 1% territory the further you go down the line. And so, and also on different exchanges have different liquidity. So for example, when you're on, if something's really liquid, usually its price moves faster because it's being traded more often. And if you're on an exchange that's less liquid, it moves slower. So that means if there's a big, like right now, if there was a big price spike in Ethereum, if Kyber is more liquid, it's going to catch up to that price spike quicker. And then Uniswap, for a few seconds or even maybe a minute or so, might still stay at this price. So you would then buy here and sell here. And usually that's where arbitrage happens. Arbitrage happens when you get the big spikes. So which is why it's really good for crypto. Because there's always like these random spikes that happens like on BitMEX or other centralized exchanges. And then these like lag behind. So we're gonna have a simple node application that's actually gonna read the prices from our smart contract on two different exchanges, and then whenever they fall out of sync, it's gonna immediately buy on one exchange and sell on the other. So let's get started with that. So that's basic data that you can read from the contract. And if I click on write contract, there's a few things you can do. One is you can withdraw Etham tokens. What all this function does is it allows you to get all your money out of your smart contract. So you made a bunch of money. So you send money into your smart contract. It's held there. You execute the trades inside your smart contract. And then when you're ready to get your returns, you're going to withdraw it. Without this function, you can't get your money back. You would just send money to a smart contract and then you can't get it. And so only you, the creator, can do this. Just like only you, the creator of the smart contract, can do a Kyber to Uniswap ARB trade. Okay? And hint, Kyber to Uniswap, you're going to buy on one, sell on the other. These might be in the wrong order. Hint for your homework. Right? So you might want to check that out when we look at the smart contract. Okay, and basically you say the from address is just a token address. This is like DAI, or what they call Psi now. Psi is the new name for MakerDAO's stablecoin, and DAI, the new DAI, is a multi-collateral DAI. But they're both the same thing. They're both stablecoins that are pegged to the dollar, but they will fluctuate in value. So they're not technically the same thing, but very similar. So we'll refer to DAI as Psi. I'll use them interchangeably in this video just because that change happened the other day. And that's something else I'd like to talk about with crypto. If you're getting into DeFi, things change very fast because this is a new industry. So for example, what was DAI in the last video is now Psi. And that confusion leads to a lot of arbitrage. So usually when people are confused, there's a lot of ARB. So there's ridiculous amounts of ARB right now because people are confused. I die ARB, Psi, or my Psi ARB, my Psi. What's going on, die? Okay. So we have a Uniswap contract, which is, I'll talk about the difference between Kyber and Uniswap. But for Uniswap, each token that you trade has its own smart contract market. Whereas in Kyber, you interact with one contract for any market. Okay, so that they're a bit different. And so we'll talk a little bit about how they work when we look at the Solidity code. And then you put the amount. How much F are you going to be buying and selling? Okay? And we start with DAI. So in order for this contract to work, I'll go up here to my URL. I'll just switch this to address from DApp. It'll give me the actual smart contract. So here we are now. And here's a simple smart contract. Now this one is one that has an error. So let me double check. This is the right actually, let me go to the right contract. Very similar, but they're two different contracts. The one that you actually have in your draft, here we go. So there we go. This is the correct contract, this one up here. And I believe the one that you'll see, okay, so you have a different one. So I'll update that so that you guys, when you look at this, all can see the proper smart contract that works well. So I'll save that. So by the time you see this, you'll be looking at this contract. So same thing, if I go to DApp up here, you'll see the same kind of information. So read contract will have the prices, write contract have the same functions. But this one just works a little better, obviously. So this one, our ultimate goal is to do this. We're going to buy on one exchange. So you see these transfers, 5-way, which is a really small amount of Ethereum, is moving between these two different. So I'm buying and then selling on one and then the other. And then the money's going back into my smart contract. All right. So that's essentially what's happening here. This is a basic ARB that's happening. One exchange is doing one thing, the other exchange is doing the other thing. If I click on these contracts, here's my stable coin, and then I can see, just more information on all of these transactions. All right. So what I'm going to do here, and I look at here, that's me, and then that's my smart contract, and it sends money into that, and blah, blah. All right. So let's get started with this whole thing. In the last video, we did some a lot, and if you haven't watched that video, totally check it out. Of course, just like the last video, I'm going to collapse our libraries. I chose to put these actually on the page to make it simple to understand, but usually, these will be on external files and you'll import them. It just makes it much easier when you're trying to verify the contract on Etherscan and things like that. So I'm going to Control-Alt bracket, make it smaller. So I'm folding these right now. All right. All right. So let's fold these up. Okay. And so the actual smart contract that we're going to talk about here, so we got the Kyber network, which is one decentralized exchange. Then we have the Uniswap exchange interface. So last time we just had one. Now we have two different interfaces. And we have our OR feed, which is our Oracle, to actually get pricing data. And we'll talk a little bit about how that works as well in here. And then we have our ERC20. And this interface is just so that we can interact with tokens, because they all follow the ERC20 standard. If you're not familiar with ERC20, look it up and you probably know what it is. But if you're watching this video and you don't, that's definitely something you want to go back and examine a little bit of. There's a wealth of information on the internet for beginners about how that works. So the first thing, so this contract's called Trader. I forget what our last one was called, but this one's called Trader. And the meat of it's actually happening down here in Kyber to Uniswap ARB. Okay? And just to be really simple, the big stuff that's happening is happening here. We call a function called swap token to Ether. So we're converting our Psi, or our what was DAI, our stable coin, to Ethereum here, and then we're taking the Ethereum, the amount of Ether we get back, to our smart contract. So now our smart contract has Ether, and then we're converting the Ether to the token into back into Psi on the other exchange, right? So Kyber is buying the Ether, and Uniswap is selling the Ether, and this just sets up the whole thing. So Uniswap, I have to actually set up the exchange, whereas Kyber, I don't have to do all that because Kyber happens through one smart contract. So I set the address. The address is Uniswap contract. Of course, this can be much beautiful, but this is a what do you call it? An example contract. So, but this is the meat here in these lines. This is really all that's happening here. Everything else is just set up. This function means that the smart contract can be paid, so we can send Ether and we can send DAI or any token into the contract. If I put a throw in here, if I put throw there, what that would do is it means that no one can send money to it. Okay, so I could put throw like this, no money coming to me. Okay, but we're not going to do that. We want to be able to receive money. So that this is the default function for your contract, where people send money, and then we have withdraw Etham tokens, and all this does is transfers all the Ethereum, all the balance. So I say address.balance. This is a built-in solidity. Built-in solidity code, so you can kind of, even though these variables aren't set, it's built in. So for this smart contract, message.sender.send means send to the person who's requesting this amount of money. And then the only owner portion up here is actually just means that only the person who created this contract can actually interface with this function. Otherwise, anybody, and we call these modifiers. Otherwise, anybody could just come and withdraw all the tokens. So this kind of just sets permission to who can do that. And how do you do that? Up here, when the contract is created, I set a modifier. I say only owner, and whoever creates the contract, so msg.sender, if you remember from our last video, is just the person who sent a transaction. So this happens when the contract is created. So whoever creates the contract is going to become the owner. In our constructor here, the first thing that executes, it says owner equals message.sender, right? So the owner is set to that person, and the modifier says if you're not the owner, if the message.sender is not owner, throw means stop. Just break. Throws like throw your hands up, like nothing is not happening. Okay. Otherwise, let it pass. And so what we're doing here, when we create a function, we can then use those modifiers to say only I can call that function. Okay. So for this smart contract, for this example code, you'll need to switch you'll need to deploy your own smart contract, which I'll show you how to do. And you'll just take this code and deploy it like we did last time. You'll deploy your smart contract, and now only you can withdraw the Etham tokens, and then only you can call the function of up here, only owner, which is Kyber to Uniswap Arb. Okay, so other people couldn't see your smart contract on the blockchain, see your transactions, and be like, oh, I can just use their smart contract, and then do it, and whatever. Even though you could open it up to anyone doing it, and if you had the proper checks in here that the prices were going to create a profit, just let other people use your smart contract. Let them send their money in, and then you maybe take a fee, right? So that's how that works. And yeah, so here we're going to, so only owner. That's how modifiers work. And then down here just sends all of the DAI tokens or the Psi tokens back to me. So all the tokens that are DAI or Psi come to me, and then all of the Ethereum balance come to me. Whoever sent the message, which the only message.sender can be only owner. So that's modifiers and how those work. And then these don't have modifiers, and so we have constant here. Constant means anyone can call it, and it doesn't cost any gas or money, right? So all of these other things that are not constants actually change the blockchain in some way. When you're writing to the blockchain, making a change, making a trade, you have to pay gas to the Ethereum miners, who are actually the decentralized group of people who are keeping this whole thing working. They need their money. And actually that's going to change very soon about how gas works. So again, DeFi, everything's changing. Ethereum is going from the current Ethereum 1.0 to Ethereum 2.0. We're like at 1.5 right now or something like that. But like we're going to 2.0, which is just a fancy term for everything's going to scale more. You can do more transactions and things like that. And one thing is that they're focusing on fixing is the actual gas. So when you watch this video, how we deal with gas might be different from how you deal with gas. But that's exciting. And when that change happens, there's even a gas token you can trade. So the value of that fluctuates. You could do arb between one exchange and the other one for gas token, or any token for that matter. And so all we're doing here down here on these constants is we're just reading data. And so we're using our OR feed object just like we did last time. And we say get exchange rate. And one thing that we're doing differently is that in OR feed, the third parameter, so you can put in different, F, die, psi, different things like that. Actually, we'd want to get psi, so that's that hint for your homework. You might want to do psi instead of die when you're getting, because now die will be the new multi-collateral one, and yeah, die psi. But what we're doing here in the third parameter is we're actually allowing you to get your data from whatever exchange you want. So this one gets the buy price from Uniswap, and this one gets the sell price. So if you go over here to the ORFeed GitHub and you look at the README, we're going to put a list. So you can see down here we have just like this kind of crude thing. But we're going to make a formal list of just as more exchanges and more platforms are added to ORFeed, you can just kind of just type in, you want the buy price for this exchange. I want the sell price for this exchange. So this will get the data from, and it'll get the data in the same exact way. So it's like I don't have to learn all the different, Kyber does it one way, Uniswap does it another way, kind of thing. So I get the data from here, and I say for this mini token. Now this might look like a lot, but this is only like one. So 18 zeros for die, and for F is just one. So 1, 2, 3, 4, 5. So it's like one F, whatever. So for this amount, what's the price going to be? Current price. And then down here, the current price that's returned is this. And so that's what produces these numbers up over here. So if we look back at our DApp, if I go here to DApp, this is not the smart contract. Let's go here. Here we go. So if I go to DApp like this, then I'll see these. So these are constant variables. They can just be read. Now, if we were to write to perform a trade, I'll need to connect Web3 with this. And as long as this, whatever address I'm on right now, is correct, I can do Kyber to Uniswap, and I'll put 0. The from address is just the psi stablecoin. So that, and if you want to find this data, just type in, like, for example, psi or die. So if I type in psi, I'll see the stablecoin for psi, which is this. So this token is the one that I want to trade, and that'll be the same as this. See here, the die address, which is now psi, as of 2 days ago. So that's the address I want to trade. So this is in the future when you want to change to different ones and different things. And then the Uniswap contract. So for psi or die, that Uniswap contract is, and if you want to find it, just go like this. Uniswap : and then you can find all of the different exchanges. So I'll type in die, because they haven't updated their information yet. So eventually this will be Uniswap psi. So, like I said, confusion, everyone's confused. This creates a lot of opportunity. So as an arbitrager, you like this kind of stuff. Everyone's confused. And then I will take this and put it inside of here. And then I'll put the amount, which is like 0.00005. Because 5 with 18 zeros, would be like 5 Ethereum. So this is a really small amount. So I'll click write, And so my MetaMask up here will say, hey, do you want to make this transaction? Now the gas fee, depending on whatever that's set to, I can edit it. Right now it's set to 5. I'm going to set it to 7 so it goes through faster. In the future, we won't be able to do this in Ethereum 2.0. It's like a year from now or something like that. Confirm. And now, just to show that this works, I'll actually execute ARB. Buy on one exchange, sell on the other. Now, what we didn't do is check whether one price was lower than the other. All that function does is just executes. We have another function that reads the prices. So that brings us over to our Node.js application, and so of course we have to wait a second for this to, and as you can see, look, even MetaMask is like, hey, there's an update to DAI, blah, blah, blah. Change out your stuff. May detect that I have some old DAI or something. So this says it's going to go through slow. Now, again, remember, for MetaMask, you can always go in and click speed up, and I will update that to a 10. So for the point of this example, we don't have to wait. Oh, looks like before I got that in, it already went through. All right, so there you go. I just did. Great. That's smart contract. Wonderful. To deploy it, of course, you just go to Remix. And now in the last video, I did the old version, the OG version, but I got feedback. People want to see the new version, how people do it today. And actually, it's very similar. It's the same. So you would just take the code from that I just showed you, put it into here. You select which smart contract you want, so trader, and then you would just click deploy. And as long as your MetaMask is connected, you set your gas price to whatever you want, click confirm. MetaMask will either pop up on its own, or you can do like this, and then this will deploy the contract. Okay, and then you can watch the other video again to see exactly how you can verify the contract code, because if you want to use the DApp on an Etherscan, you need to verify the code. And if you just want to interact with it directly, you can just do it through here by basically deploying, saying what address it's at, and then calling different various functions through here by clicking these buttons. So there you go. So now our smart contract is deployed, right? We have a smart contract that executes ARB, that can read. Now we need something that's just going to run in the background and is going to check the prices all the time on both the exchanges. And then when it sees an opportunity, it's going to basically call our smart contract to execute the trade. So let's talk about that. So back over here in ORFeed, so of course we have examples. And if you look in the example code, you'll see now there's basic ARB example. So last time we talked about the basic node example. And this time we're going to talk about the basic ARB example. So just like last time, what you're going to do is, let's say, let me just pull this up like this. When you clone the repo, it's gonna look like this. Now, actually, I'll go ahead and do it again, just so we're all on the same page here. So you're gonna open up your terminal. Make this really big. Now, yours is probably white or black or whatever, but I have like my settings on my terminal. So if your terminal doesn't look the same as mine, you could be cool like me and update your settings. But otherwise, here we go. So I'm just going to go on here, and I'm just going to do I'm going to cd change directory into desktop. And like I said, I just have on my desktop, I just have an apps folder. I just keep all my stuff in there. So I'll say git clone. I'll paste the address in, and I'll give it a name. I'll say ORFeed example 2. Okay. So this will create a directory called ORFeed example 2. I'll cd into ORFeed example 2. I'll open that file, or open that folder, example 2. And look, okay, so this is what you'll see when you fork everything. And then now you'll click on examples. And I highly recommend just taking this folder, basic ARB example, and then moving it into its own folder. This is probably best. So that, like, if you find something, or you want to push something up and update our ORFeed code, or you have an idea and you want to put something or update a README, you don't need to update like the ORFeed repository. You just take the example out on its own into its own folder, and then because it's its own app, we just keep it all inside that repo so that you can do this. So I think this is the best way to do it, but do it however you want. So I made it its own folder, and now what I'm going to do is we're going to go through that code. So here's what's happening there. I'm going to open up our Atom. So here we go. So if you look at basic ARB example and you go down, so let me just collapse this so the focus is on this. So this is the one we did last time, the basic node example, just reading and then executing a single trade. Here, what we're going to do is we're going to go open our index.js, which is our main file. It's very similar to what we did last time. The first thing you're going to need to do is go over to the folder, put it into your terminal, and you'll need to do an npm install. This will download all of the modules that are needed. Let me see. Or feed example 2. So here, we'll feed example 2. Oh, yeah. So I meant to say that you're going to take the basic ARB example. So like basically in examples, basic ARB example, you're going to take that and you're going to create its own folder. Okay. All right. Here's basic ARB example. Okay. So now I'm in basic ARB example, and the first thing you're going to do is npm install in your Node application. Okay. So I'm installing everything. This will take a second, obviously, because it's installing a lot of stuff. And remember that all that information comes from our package.json file. So in the package.json, we have, and we'll go over that, package.json has all of our libraries. So this is like, hey, I want you to install Express, which is the app that actually serves it to the web, lets it exist on the web. Cores, which is not actually needed for this. SHA3, which is just a basic hashing library for like Ethereum transactions. Infura, Web3 provider, Web3. Web3 obviously lets you interact with the Ethereum blockchain. This is probably the most important one. And then play sounds, because I keep saying that later down the road for like ARB stuff, we'll have like one that plays a sound when there's an opportunity or something like that. So we'll do that eventually. Just to keep everyone excited. And essentially, once everything's installed, here's what's going to happen. You put npm start. So we run our application, and I'm showing the end case of what's happening, and then we'll talk about kind of what how it works. So here, as you can see, it just keeps updating. It says Uniswap Psi buy price is this, Kyber Psi sell price is this, and basically it just keeps updating. So you can see it just updates constantly. So it's constantly checking the price, and it's constantly telling us, and it says no ARB, no ARB. So because the price right now, this is what it usually will be until there's like a big spike, like once or twice or 3 times a day. There's like that thing that happens, and it's not just Etham, DAI, or Psi. It's all the tokens, right? So in that 1 or 2 or 3 times a day, or sometimes it's once every 2 days, depending on the volatility of the particular time, you could have this running for like hundreds of tokens. But this is just one simple example. So it's just like no ARB, so it's checking, no ARB, no ARB, no ARB, but it's printing out the prices. And then also, this is deployed. You can check this on your local host. You can go to localhost, and if you want to deploy this to your Heroku server, you can watch our last video where we did that, right? So where you can put it on the web. But if you want to see port 5000, I'll open this up, and there I go. Uniswap buy price, Kyber sell price. Just simple data. And whenever these are inverse, we want to execute our trade, right? And this thing is just printing out to our console what's happening. All right? So this is our monitor, simple monitor. All right? Now, let's talk about the code. So first, let's see where it's reading index.js. Okay, so this is our Node.js application. Let's first, and we talked about all this stuff up here in the last video, but just to review, we're just establishing all of our variables. And basically, we're just saying, okay, we're telling ourselves that we're starting, we're setting up Express, which just serves it to the web, which allows us to, do stuff like print like this. And then we're just getting all of our stuff set up. And the new stuff that we have is the SI buy price for Uniswap, the SI price sell for Kyber. And if you made it this far in the video, hint, hint, these are swapped out. So you'll probably need to update the smart contract because you're buying on Kyber and you're selling on Uniswap. Okay. So just hint for your homework of what you're really doing here is your smart contract's going to need to, since we're actually buying on Kyber, you'd want that price. And since we're selling on Uniswap, you'd want that price. So so what we're doing here is we do a thing called a set interval. Now, this is a very crude way. If you're a developer, you're like, what? Why are you doing an interval? There's a very crude way of doing it, to just explain. So every 3 seconds. Hell, I could make this every 1 second or every 1 millisecond. So it could be really real time. So right now, it's just showing every 3 seconds, it's going to get prices. And get prices is just a function. And if you ever want to find some, just Command F, get prices. All right, there it is. So there's my get prices. And all we're doing here is we're saying, okay, here's the contract address. This is the one we just talked about, the one we just looked at. Get the ABI. And to get the ABI, you literally just go over to, well, actually, you can get it directly from Remix. When you write your contract, you can go up to here. And somewhere in this new UI, they have a place where you can copy the ABI. But in the old UI, there's a thing. So let's see, where do they put it? It's somewhere in here, all right? But over here in the Ethereum, if I click on this contract, on Etherscan rather, you can just go to the contract once you verify the code, and you can just go down and then just copy this. There's your ABI. This is just the interface for this to interface with it. So I have my contract. So I say, okay, here's a new price contract object, and use Web3, which we imported, right? And use F contract. Here's the ABI. Here's the contract. So basically, this is now the smart contract, but in my Node application. And now I can do things like for get prices. I call the method get Uniswap buy price, which is just this function that's in my smart contract, get Uniswap buy price, which returns this. So I call that, get the data, and then I set SI price by Uniswap equal to the data. And I also console.log it. That's why you see this happening down here. If I do start again, it starts up. It's just printing that out. So I say console.log, just print Uniswap buy price is, and then console.log it, Uniswap buy price is console.log. And the reason, remember, it's running over and over and over and over again is because I have an interval set that gets prices. And I have another interval. And so that's basically how that works, right? Like, it's just printing out. So what you could do is you would just change this information to whatever functions that you have, or just go directly to ORFeed. You create an ORFeed object and then call and get the price data directly for this. And you just get the data. So this is getting the data, printing it out, setting variables to it that originally start as 0 up here. So if you look up here, these are all 0. And we have currently trading equals false. We'll talk about that. So we have a variable called currently trading equals false. And the reason for that is over here. Maybe I should make this bigger so people can see it better. Some people got bad eyes, right? So this is the meat of what we're talking about. So Arbitrage says, hey, if currently trading is equal to true, don't do anything. Return false, which means return, stop. And then it sets currently trading to true. It says, hey, we're currently trading. So if it gets called again, it won't do anything. But it sets a timeout to say currently trading should be false in 45 seconds. Again, a crude way of doing it. But this is like example code. And so for new people, this is just kind of like, a simple way to do it. Not necessarily the best way, but a simple way that gets the job done. So what this means is that since we have an interval running all the time, we could see that the prices are out of sync, and then we could execute the trade, but then we keep executing the same trade over and over. And we don't want to do that. We want to execute the trade once and then check again. So this says, 45 seconds, the first transaction should have went through. And then now it can, if the ARB still exists, then it'll run again. So it says, okay, if it's true, don't do anything. And if it ever is, so currently trading starts out as false. So the first time it ever runs, it says, oh, it's false. So just skips this, then sets it to true, right? It says, okay, now I'm trading, all right? And then it says, hey, in 45 seconds, make curly trade false. So in 45 seconds, it can actually run again. And then all it does there is it says, okay, where's the smart contract? Oh, here's my address. Here's my private key. Right now, of course, this is not the real address and private key. You'll need to put your address and your private key for your wallet, right? So, for example, if you deploy your contract, if you're over here and you deploy for MetaMask, you can get that information. You can click this to copy your address, and you can just paste that into here. And then if you want to get your private key, just go over to account details and then click export private key. And then you'll just put your password for your MetaMask, and then you'll be able to see your private key. And then you'll just paste exactly what's there into private key. And then you put the contract that you deployed, the address that you deployed, you'll put it there. And now, because of the only owner modifier, only that address can call. And then you'll just create your contract the same way we did earlier, taking the ABI that we got and our trade contract, which is the same contract. And then we create the transaction. We say methods instead of .call. We say we do this one, methods dot the function. So this is just the same function we showed earlier that we executed. Remember over here on Etherscan, this basically just does this transaction, buy and sell on one, calling the function of. And if I click over here, you can see, look right there, Kyber Uniswap Arb. From address, Uniswap contract, the amount. And then you can see the data in here. And all these extra zeros are just what we call buffers. We'll talk about that later. And then this is just a hexadecimal representation of 5000, whatever I put in. Now, hexadecimals, if you're not familiar with them already, can get weird. If I had to describe it in a tweet-like format, I would say it's just a different way of expressing numbers. The computers have their own way of understanding numbers. And they like hexadecimals, specifically the Ethereum computer. Much more complicated than that, but I think that's the best way of saying it. It's like English and Korean. You could say hello or, 안녕하세요. Mean the same thing, just a different way of saying it. Okay? There you go. Hexadecimals versus integers. Yeah, that's the best I got for now. And so Kyber to Uniswap ARB, I'm just putting those parameters in. Here's the Psi token address here. And then the reason I set it up like this is so you could just put in whatever tokens you wanted down the line. And then here is the Uniswap actual location. And then here's the amount I want to trade, just like we did last time, which is like a really small amount of Wei. Like Wei is just a form of Ethereum that's like a really tiny amount. It's like cents to the dollar. $1 is what an ETH is, and then 1 Wei is like what cents are, but like Wei is like 0.0000000000000. Yeah, like that. And then I put the gas amount that I want to pay, and then I send value over of 0, right? And what this will do is I'll actually just execute the trade. So if I want to just test to see if this works, because right now it hasn't found any ARB, right, in this very moment. So I'll close this, and I'll just, this condition down here we have that says, hey, if I go to my trade, so here, it says set interval every 5 seconds. Oh, you might wonder, what's 5,005 seconds? So this is in milliseconds. So 1 millisecond, that's how computers work, right? Like every 1 millisecond, 10 milliseconds, yeah, 100 milliseconds, and then every second would be, if this is a 1, so it's every 5 seconds. Okay. And so what we're doing here is we're saying, hey, if the buy price on Uniswap is less than the sell price on Kyber, then do the arbitrage. Now, of course, your homework is to go to the Solidity code, update these variables to get it to work like you would want it to work. Technically, if they were off, it would still technically work because one would be off the other, but you would that's not how you would want it to work, right? So you need to look through that, resolve that. And if you have any questions, I'm more than happy to help answer them in the GitHub. Just leave an issue or leave, just a comment or whatever. Maybe we'll create a getter or something. And then, so then we call arb trade. And what we'll do now is we'll say the opposite. So basically, if we're not going to make money, right, this is what it usually is, then do the arbitrage. So I'll save that code. And actually, this isn't that code. That code is actually open basic. What I mean is it's the same code, I just have it in a different directory, is what I mean to say here. So here in index, I'll just open that up here. So this is that, and I'll go down to the bottom, and I'll just swap this out to the opposite. So this is what it should be, less than, just like in this contract. And then if I change it to greater than, this is the opposite thing. This is we're definitely gonna lose money, right? And then I can run npm start again. Now save that, and so now we get the prices, and then it'll immediately actually run the trade. Hey, check and see they are. All right, and so there's the trade. Now the reason is there's insufficient funds because I'm not sharing with you my real private key. Sorry. So if you plug in, and I've tested this, so as we saw for the previous transaction, if you have your proper address and your proper private key that actually deployed the contract, then it won't say that you don't have enough money. You'll need to put Ethereum in to pay, but also you'll need to send in DAI, or rather Psi at this point, Psi into your smart contract, because your smart contract needs money in order to do the trade. Now, how do you get, if I have Ether, how do I get Psi, whatever? Okay, well, just like you can go to Kyber, kyberswap.com, and then you could do it here. You could just take your Ether, and this is exactly what we're doing on an automated fashion with our Solidity and our Node application, right? But I can say, hey, you know what? I need some Psi. I really need some Psi. I've been looking for some Psi lately. You just do it like this, and you'd say, hey, 0.02 swap token, connect with MetaMask. It'll usually have a pop-up, but I already approved it. So I'll get $3.4, 3.4 DAI. I'll click confirm. It's going to put a 10 gas, which they kind of already set to be, something that'll go through relatively fast. In this moment, tomorrow, 10 might be excessive or under. I'll click confirm. And then, so now I have Psi. And then what you'll need to do from there is actually send the Psi to your smart contract. So I have my Psi here. I already have Psi, so I don't have to wait for that to confirm. I have Psi. I'll click on it, and then I'll go to the smart contract that we just deployed. So here's my smart contract. Oh, no, that's me. Here's my smart contract. 1114. And so here was our trade that we did. Here's the number of tokens that it has. It has 50 cents. I'm going to send it some more. So I'll click on this, click back over on my Psi. Oh, I got more now. That was for my conversion. And you'll send that to your smart contract. And I want this to go fast, so I'll save it to 10. Confirm. How much did I send? I sent 0. Let me send more. So yeah, don't make that mistake. I think that MetaMask should make it easier for you to know that. Warning, you're sending no money. Why would you do that? That's a UI request I have to the MetaMask team right now. So here's my Psi. Send to this address. And yes, I'm going to send all of $1 in Psi. Yeah, so it might not look like it updated. That's just MetaMask jank. Occasionally MetaMask doesn't update properly because it runs on React in a really weird way and imports Web3 through a very interesting method. But, you know, we do what we can. We work what we got. There are alternatives, of course, to this. Our very own TAL that we are working on, and as well as today available, there's like Firmatic, Portis, all these other different platforms. So those are useful as well, but they don't work with everything, which is, I guess, the problem, right? So if you want something that works with everything right now, the not best, most usable thing is this, but it is universally working. And it gets better every day. So yeah, so I sent the tokens over. So then on your smart contract, it takes a second, but you should be able to see an update. So if your smart contract doesn't have a token balance of some psi, then it's not going to work because it needs to actually hold that money, and then you tell it how much it wants to trade. And then when you want to get your money out, of course, you can just go to the contract, actually go to your contract, write contract. You can do this instead of going to actual DApp and withdraw. And so you can just click write, and it'll say connect your Web3 provider, connect to Web3. Now I can write. So I can call this function, and I can get all my money back, right, when I'm ready, right? So just sends information over, all the money will exit out of the smart contract, and that will be in my account. All right, and so, so there's your homework assignment, is actually execute some trades, deploy it to actually work for you, maybe switch it to lose a little bit of money, a few cents or whatever, not even a few cents because you do really small amounts. And you see this is just still running. And like I said, if I don't want this running on my computer all the time, just do what we did in our last video where you deploy it up to Heroku. So it's already set up to do that. And what I'm going to do right now is I'm going to update so that when you look at this, updated what was it? The smart contract example. And so this was actually the wrong repo. So this has nothing to do with our class right now. This is just me trying to make your life a little easier when you actually do look at this. But it can be useful for how to do work with Git. So of course I'll do the same thing. I just did updated the smart contract, and then I'll go ahead and what I'll do is I'll push that up. So by the time that you see this, you won't have any issues. Virgin master. All right. And that, as you know, that this is a very similar way that you would deploy to Heroku through using Git tools. And I actually have two repositories that I try to keep up to date on with this. So this makes sure that both of them are updated. And so, yep, you can follow this example just by going to this repo. And as you'll see, it'll probably say, 33 seconds ago, stuff was updated, right? And you can also see what was updated, what changed. Okay, so there's your smart contracts. There's your examples to review. You're going to go into examples, and these are where our node applications are. So for this one, we use the basic arb example. So that's where your homework will be. You'll copy this folder, take it out, put it somewhere else, and then deploy it to Heroku or just run it locally. And then for contracts, you'll actually probably start here. You'll need to go to trader example, and inside of the example, you're going to change, hint, hint, if you made it all the way to the back at the end of this video and you're not falling asleep yet, right here is what you want to look at, right? You want to change this probably to psi, so that from OR feed you get the actual psi price, not the DAI price. And you probably want to, since we're buying on Kyber, you probably want to change it to get Kyber buy price and get Uniswap sell price. So change the functions. And then in your node application over here, you're going to want to actually update the functions that read, or read from OR feed directly, right? But over here, when you call your smart contract, you'll be calling the get Uniswap sell price, get Kyber buy price, and then this will be called get psi buy, whatever. So you'll switch these up and this will be very frustrating. It'll give you headaches, but the great part is if you actually do it, you'll really be in control That's why we also record this video so you can go back and like try to understand it. But you'll be in control of like really understanding how to change things. So then you can add more tokens. Then you can kind of become an autonomously arbitraging DeFi animal, right? And that's what we want. Or a robot, whichever you consider yourself. And now, thank you so much for watching this video. If you have questions, of course, you can leave them in the comments. And that is our quick tutorial on executing arbitrage using data provided by Orfeed with the Node.js application to monitor price data and then execute your trades. Thank you very much for watching. And may the proof be with you.